Today, we're talking about type 1 and type 2 errors, what they are and what they mean. Stay tuned. The idea of type 1 and type 2 errors is really a basic idea in epistemology, or the study of how we know things. It reflects the difference between our beliefs about the world and the actual state of the world. We either believe something is true about the world, or we don't believe that something is true. Now, not believing that something is true is not the same as believing it's false. If you want more on that logic, please see my video about the null hypothesis and why we test it. But the point is, we either believe something is true or we don't. Now, in the actual world that we live in, it is either true or it's not. When we're correct and we say something is true when it actually is, then there's no problem. After all, we want our understanding of the world to best match the world in which we live. This is going to allow us to make our best decisions about what to do in this world. However, you'll notice that in some cases, we are wrong. And we're wrong in one of two ways. The first way is to believe that something is true when it actually isn't, a false positive. This is called a type 1 error. Another type of error that we can make is a false negative. In other words, we fail to believe something is true when it actually is. That's a type 2 error. Now, both of these errors are bad because they mean we're not accurately representing the world. However, we can ask the question, which one is worse and which one do we prefer? What are the costs of being wrong? Well, it really depends on the situation. For example, if I'm camping in the woods and I hear the bush rattle, I might believe that it's a bear and run away. If I make a type 1 error, that is, I believe it's a bear, I run away, and it turns out it was just the wind, I haven't lost much, maybe some time camping, some enjoyment. On the other hand, if I make a type 2 error and say, it's probably the wind, but it actually is a bear, then I'm going to be that bear's dinner. So the costs are much higher for making a type 2 error than making a type 1 error. In this case, I think I should avoid making type 2 errors. In fact, some evolutionary psychologists believe that this is why humans are so prone to superstitious beliefs. They have an animistic bias that makes us believe something is out to get us when it isn't, because that may have provided our ancestors with a survival advantage. Let's take another example. What about pregnancy? Is it worse to think you're pregnant when you're not? That would be a type 1 error. Or is it worse to think you're not pregnant when you actually are, the type 2 error? Doesn't it depend on the person? If I'm trying to have a baby, I'm likely to have a very different opinion about which one is worse than someone who is definitely trying not to have a baby. All of this is just to say that which one is worse, type 1 or type 2, really just depends on the situation. And you can see how you might want to bias your behavior towards avoiding one type of error or another. In science, we want to believe as few false things as possible. Now, this is because of the parsimony principle. And again, if you haven't seen the video on why we test the null hypothesis, really recommend checking out that video because it has a lot of details on this idea. But basically, type 1 errors are superstitious, and they violate the law of parsimony. Type 2 errors are more conservative, and then they simply say, I don't have enough evidence to believe that this is true, at least not yet. Because type 1 errors violate parsimony, science tends to bias away from type 1 errors with less concern for type 2 errors. This is what it means to be conservative when you talk about statistics. Typically in statistics, we set a goal for ourselves. We draw a line in the sand about what an acceptable chance of making a type 1 error is, and we call this value alpha. Usually, alpha is set to 0.05, or a 5% chance of making a type 1 error. That means we'll be right when we say we believe something, we'll be right 95% of the time. Now that still leaves 1 in 20 times we will make a mistake. We will believe something is true when it's not, which is why things like replication and further confirmation of our beliefs are necessary. If alpha is our type 1 error rate, in any experiment, we want to keep this error rate constant. We don't want to go above that value because we said that was the minimum error rate that we would accept. In statistical tests, we often calculate what's called a p-value, which is roughly the probability of observing these data given the null hypothesis. I'll go into more detail on this in a future video. But the basic idea is if the p-value is less than alpha, then we say the chances of making a type 1 error are acceptable. We're more than likely correct about there being a difference here. In other words, alpha is a decision point, and we're looking at whether our p-value is below that line or not. In football terminology, alpha is like the first down line, and the p-value is the position of the football, right? And we set our alpha, and then we look at the position and we see whether or not there was a significant difference. So p-value is not the same as alpha. Now, one last thing to keep in mind. If we conduct multiple statistical tests with an error rate of 0.05, the error rate is actually going to go up. Just like flipping a coin once gives you a 50% chance of getting a heads, if you flip the coin 5 times, you're going to have a much greater chance than 50% of getting at least one heads. Similarly, if you run a bunch of statistical tests, each with a 5% chance of a false positive, you're going to wind up with a much bigger chance of finding a false positive. So as a general rule, you want to minimize the number of tests you run, and when you do run multiple tests, you need to make sure you incorporate some kind of correction to help deal with this issue. And we'll cover that in a future video. I'll walk you through the details. For now, I hope that helps explain type 1 and type 2 error, why scientists prefer to avoid a type 1 error at the cost of making more type 2 errors, and how alpha and p are different from each other, and alpha is used as a decision line to help prevent us making type 1 errors. Okay, I've got more videos on the way. If you want to see those, like and subscribe. We're going to look at how those concepts build upon each other to help understand the idea and the logic behind statistical inference. Until then, keep thinking.